Hello students, so welcome to one more video. Today we are going to discuss a very important topic from class 11 from the chapter of Newton's laws of motion. Now those who have studied Newton's laws of motion, you know that in Newton's laws of motion, this particular topic, free body diagrams, they are extremely important. Okay, so today we are going to discuss about this free body diagrams. Now if those who don't know what are actually free body diagrams, first you need to know what are Newton's law, Newton's first law and second law. Now see, Newton's first law states that if there is a body and if you apply force to a body, then that particular force may cause an acceleration to the body. Okay, that means if there is an acceleration to the body, there must be a force which is being applied to the body. Okay, and from Newton's second law of motion, we see that that particular force will be equals to mass into acceleration. We can derive this from Newton's second law of motion. By the statement of Newton's second law, it states that the rate of change in momentum of a body is directly proportional to the force applied. So from that we can derive this equation. That means that if a force F is applied to a body and the mass of the body is m and the acceleration produced in the body is a, then we can write F equals to mass into acceleration. Fine. Now what are these free body diagrams? Now see students, these free body diagrams are basically examples of real life bodies where multiple forces may act on the body, and in these different cases we have to find out the acceleration which is being produced in the body. Okay, so these are basically examples from real life motion. Okay, in real life the objects that we see where multiple forces are acting on the body, and our main task will be to find out the acceleration which is being produced in the body. Okay, so today we are going to discuss about these free body diagrams. Okay, so let's start. Now the first one will be a very easy one. Okay, I am starting with the easiest one. Number one is a block which is placed on a horizontal plane. A block which is placed on a horizontal plane. Okay. Now, the important thing is to follow the procedure which I am telling you. Okay. To find out the acceleration, you need to follow the procedure, because you see, in the exam you might not remember all the formulas. There will be lots and lots of formulas. So it's very important to understand the concept of how to solve this particular numericals. Okay. So over here, subdivision 1, I am telling you, see, suppose I have a horizontal plane. Okay, I have a horizontal plane in which a block is kept, right? And I am applying a force to the block. Number one will be, if I apply the force horizontal, force is applied horizontal. Force is applied horizontal. Right? Okay. One more thing. Over here, I am not considering the frictional force. Fine. Now see, in many competitive exams, whenever these free body diagrams come, they give you with the frictional force. In most of the numericals, they give you with the frictional force. But over here we are discussing without the frictional force. Okay. Afterwards, I might make a separate video where I will teach you these free body diagrams considering the frictional force. But over here, for now, I am doing it. That is, all the numericals, all the free body diagrams, I will be doing without the frictional force. Okay. So suppose this is a body. This is a body. Okay. And over here, I am applying a force in this direction. This is the force which is being applied in this direction. Suppose the mass of the body is a. Fine. So this force will produce an acceleration on the body a. Okay. Now our task is to find out the acceleration. Okay. Now, before finding out the acceleration, we need to see what are all the forces that are acting on the body. Okay. We have to see what are all the forces that are acting on the body. Then at last, we will make equations, and then we are going to solve out, we are going to find out the acceleration. Okay. So this is mass, you see, one force will be acting in this direction, that is mg, right? And we know the surface will also give a reaction force. that is R. Right? Okay. So now we are going to sort this. So this is your first task. Your first task is to mark all the forces that are acting on the body. Okay. Next, your next task is to find out the equations. Okay. Now see, there will be two types of equation. One will be along the vertical direction. One will be along the horizontal direction. You see, in the vertical direction, these two forces are acting. And in the horizontal direction, over here, there is only one force. Okay? So see how to do. In the vertical direction. Okay. Now, this force I have applied on the body in this side. Okay? This force I have applied on the body in this particular side. Okay? And the body is moving in this particular direction. The body is moving in this particular direction. There is no motion in the vertical direction. Vertically, the body is not moving. That means we can say mg and r, they are equal. Okay, we can say mg and r, they are equal because vertically the body is not moving. So I can write r will be equals to mg. So these two forces are getting balanced. Okay. If the body was moving up or if the body was moving down, then we could have said that R is greater than mg or mg is greater than R. Then there would have been a resultant force which is being acting on the body. But over here, vertically there is no motion on the body. So vertically these two forces, they are balancing each other. So R will be equals to mg. Fine. Or from here we can write R minus mg equals to 0. Okay. Now see, in the horizontal direction. In the horizontal direction. Now see, in the horizontal direction, only one force is there, F. Okay? And we know F is always equal to mass into acceleration. Okay? F is equals to mass into acceleration. This one, as I said earlier, you can derive from Newton's second law. So from here we can write acceleration will be F by m. So this will be the acceleration which is produced in the body. So this is a very simple case. Number 2, subdivision 2. Now see, over here, I had applied the force horizontally, but also I can apply the force at an angle. Okay, suppose this is the body, and suppose I am not applying the force horizontally, I am applying the force which is inclined at an angle in this direction. In that case, how to find out? So number 2 is force is inclined at an angle. Force is inclined at an angle. But there can be two types of force. You see, if I am applying the force which is inclined at an angle, either I can pull the body or I can also push the body. Okay, I can either pull the body or also I can push the body. Suppose I am pushing the body which is inclined at an angle. In these two different cases, let us see. So number A. Okay, number A, I am doing pulling. So if I am pulling the body, okay, if I am pulling the body, suppose this is the body of mass A. And I am applying the force in this direction. In this direction I am applying the force which is inclined at an angle theta. This force is inclined at an angle theta. Okay. First, let us mark all the forces that are acting on the body. This will be mg. This will be r. Okay, no problem. Okay. Now see, if I am pulling the body in this direction, this force I can divide it into two rectangular components. Those who know vector, they will be knowing this force I can divide into two rectangular components. One component will be in this direction, another component will be in this direction. Okay. So if this is F, this one will be F cos theta and this one will be F sin theta. Okay. So F cos theta and F sin theta. Right. So these are all the forces which are marked on the diagram. Now let us see the equations. So in the vertical direction. Now, if I am applying the force in this direction, of course there will be an acceleration which is being produced in this direction. You see what is going to happen? If I am applying the force in this direction, one component is applied in this direction, another component is acting in this direction. Now, since there is no vertical motion, we can say that F sin theta and R, these two forces together, they are balancing the weight mg of the block. Okay, F sin theta and R, these two together are they are balancing the weight mg of the block. And this component F cos theta, it is producing an acceleration on that side. Okay, so both these different components have different roles. You have to understand this one. F cos theta is producing an acceleration on this side, and F sin theta along with R, these two are balancing the weight mg of the body. Okay, so we can write F sin theta plus R will be equals to mg. Right? From here we can write R will be equals to mg minus F sin theta. This is your equation 1. Okay. Now A is the acceleration of the block. Okay. In the horizontal direction, which force is acting, which component is acting? You see in the horizontal direction, F cos theta is acting. Okay, F cos theta is acting in the horizontal direction. So I can write horizontal direction. In the horizontal direction, I can write F cos theta will be equals to mass into acceleration. Okay, mass into acceleration. Remember what was our task? Our task was to find out the acceleration in all the cases. Okay, so acceleration will be equals to F cos theta divided by A. This will be our acceleration. So this is when I am pulling the body. What if I am pushing the body? If I am pushing the body, in that case how to find it? Suppose I am pushing the body. This is the body, fine? Okay. So suppose I am pushing the body from this side. I am pushing the body by force. Okay. Now let us mark all the forces first. Suppose this is acting at an angle theta. This angle is theta. Okay. So this will be mg. This will be r. This will be mg, this will be r. Fine? Okay. Now those who know vectors, they know that if the force is directed in this direction, then the two components of the force, okay, the two components of the force, one component will be acting in this direction, another component will be acting in this direction. Okay, that means if the force is inclined in this way, then one component will be in this direction, another component will be in this direction. Right? Okay. So this component will be F cos theta. This component will be F sin theta. So F sin theta, you see, F sin theta is acting in the direction of mg. Okay, over here, F sin theta is acting in the direction of mg, and R is acting in the opposite direction. Now, since there is no vertical motion, okay, since there is no vertical motion, we can say that these three forces together, they are getting balanced. We will see that by the help of the equation. But this particular force, F cos theta, this force is producing an acceleration in this direction, F cos theta. Okay, now we need to find out the acceleration. So first let us see in the vertical direction. Vertical direction. Okay. Now see the vertical direction, mg and F sin theta. Mg and F sin theta, these two are acting in the same direction, and R is acting in the opposite direction. So we can say that mg plus F sin theta must be equals to R. Okay? Mg plus F sin theta must be equals to R. Why? Because there is no motion of the body in the vertical direction. I am pushing the body in this direction, and the body is moving in this direction. Okay, I am pushing the body in this way, and the body is sliding along, and the body is moving along the slope in this direction. Okay, so this acceleration is being produced by this particular component F cos theta. There is no motion in the vertical direction. That is why I am writing mg plus F sin theta. Why? Because you see these two are acting in the same direction. Must be equals to R, because R is acting in the opposite direction. Okay? We know that whenever a body is in equilibrium in a particular direction, then the resultant of all the forces must be equal to 0. That's why I have done this. In the horizontal direction. In the horizontal direction. Now see, in the horizontal direction only this force is there, F cos theta. It is producing an acceleration. So very easy, I can write F cos theta equals to mass into acceleration. So acceleration is going to be F cos theta divided by mass. This will be the acceleration. Okay. So this is your equation 1. This is your equation 2. Over here, this is your equation 1, and this one is your equation 2. Okay. So these are known as the free body diagrams. Okay, this is number 1. If a block is placed on a horizontal plane, okay, so I have shown you how if I apply the force horizontally, what is going to happen. If the force is applied at an angle, then what is going to happen? I can either pull the body or I can push the body. Right? Okay. Now we are going to see if a block is placed on an inclined plane. Okay, in an inclined plane, then what is going to happen? Okay. So number 2 is if a block is placed on an inclined plane. Now what is an inclined plane? This type of surface is known as an inclined plane. This type of surface is known as an inclined plane. So if I place the block over here, now many things can happen. Those who know friction, the block can either stay where it is or the block can slide down. Okay, the block can slide down with an acceleration. Right? Also, I can apply a force on the body to bring the body down, or I can apply a force on the body in the upward direction to pull the body up. So many things, we will see all the scenarios. Right? Number one is if no external force is acting on the block. Okay, if no external force is acting on the block, in that case, how to solve this? So this is our inclined plane. This is our inclined plane. This is the body. Now this angle is theta, which is known as the angle of inclination of the inclined. Okay, the angle of inclination of the inclined. Fine. Over here, first what you have to do is, first you have to mark all the forces that are acting on the body. So this is the weight mg of the body. Okay. Now we have seen that when the surface was plane, horizontal, then this was mg, and r was acting just in the opposite direction of mg. But see students, this will not always be the case, because the reaction force always acts perpendicular to the surface. If the surface is like this, then the reaction force is going to act in this manner. But if the surface is inclined, then the reaction force is going to act in this manner, because reaction force always acts perpendicular to the surface. So if the surface is like this, weight of the body always acts vertically downwards. This is the weight of the body. But over here, reaction force will not be this one. Reaction force will be equal to this one, which is acting perpendicular to the surface. Okay, so this is going to be the reaction force. Okay, now over here, the most important thing, we have to divide mg into two components. So one component will be in this direction, another component will be in this direction. Fine. Okay. Now see students, if this is theta, if this angle is theta, then this angle also will be theta. How? If this is theta, then this angle also is going to be theta. How? Okay. Okay, in the book it is not given properly. Okay, in the book it is not given properly. Why? And many students I have seen, they have a confusion. If this angle is theta, this angle is also theta. How is it possible? You see, I am showing you over here. Okay, suppose this is the inclined plane. This one is the inclined plane. This particular point over here, this particular point I am considering over here. Okay, no problem in that. No problem in that. This particular point I am considering over here. Okay, so this is your mg. This is your mg. This is theta. Okay, this is one component and this is one more component. Okay, because same diagram, just this point I have considered it over here, just to make this thing simple. Okay, now you see, if I draw this particular straight line, this is theta, this angle is 90 degree, because we know that mg always acts vertically downwards, so mg is always, this particular angle is 90 degree. So this is 90, this is theta, so this angle will be 90 minus theta. Okay, this particular angle, this angle is going to be 90 minus theta, this angle. Okay, and we know that this is 90 degree because these two components, this component and this component, okay, they are always acting 90 degree with each other, vertical and the horizontal component, they are also at 90 degree with each other. So these two are at 90 degree with each other. This, if this is 90 minus theta, then this angle is going to be theta. Okay, so if this is theta, this is also going to be theta. This is the logic of it. Easily we can prove by the help of geometry. Okay. So if this is theta, I can write this component as mg cos theta and this component as mg sin theta. Now see, this mg sin theta component, is going to pull the block downwards. Okay, the block will start to slide downwards with an acceleration due to this component. So the block, suppose it is sliding downwards with an acceleration due to this component mg sin theta. Fine. Okay. Now all the forces are marked over here. Now we can see the equations. Now over here you can write horizontal direction and vertical direction. This one also you can write, okay, or you can write along the slope and perpendicular to the slope. These two things also you can use. I am using suppose perpendicular to the slope. Perpendicular to the slope. Perpendicular to the slope. This one I am using, okay, perpendicular to the slope. Fine. Now see, this r and mg cos theta. This mg cos theta is balanced by this r. Right? This mg cos theta is balanced by this r. So I can write r is equal to mg cos theta. So r is equals to mg cos theta. And this mg sin theta is accelerating the body in the downward direction. This mg sin theta is accelerating the body in the downward direction. So I can write this is along the slope. I can write mg sin theta will be equals to mass into acceleration. Mg sin theta will be equals to what? Mass into acceleration. So from here I can write, so m and m will be cancelled. I can write acceleration equals to g sin theta. G sin theta. This is your acceleration. Okay. So this is the case where the block is placed on the inclined plane and I am applying no external force. No external force I have applied. The body is automatically sliding down. The body is automatically sliding down with an acceleration due to which component? Due to this mg sin theta component. Due to this mg sin theta, the block is sliding down. Okay. Next one. Number 2. Now suppose I want to pull the block up. Okay, I want to pull the block up. So what I have to do? I have to apply a force in the upward direction. I have kept the block on the inclined plane. I have kept the block on the inclined plane. Now I am seeing that the block will just slide down. But I don't want the block to slide down. I don't want the block to slide down. I want the block to go up. So what I will do? I will pull it up with a force. That is an external force I have to apply over here. So number 2 is a force is applied in the upward direction. a force is applied in the upward direction. Okay? So see the diagram. This is our inclined plane. This is our block. This is theta. This is mg. So these are the two components of mg. This is r. So this one also will be theta. This is mg cos theta. This is mg sin theta. Okay. And on this direction I am applying an external force. Okay. I am applying an external force in this direction. This is the external force which I am applying in this direction. Okay. Now what is going to happen? You see, from here there can be two cases. There can be two cases from here. Number one. If this force, you see, this r and mg cos theta, they will be balanced. Along the slope, they are going to be balanced. This is perpendicular to the slope, they are going to be balanced. But this mg sin theta and this f, you see, these two are acting in the opposite direction. Now, two things can happen from here. Number A I am writing. Number A is, if this force is greater than mg sin theta, okay, if this force, suppose the force which I am applying, that force is greater than mg sin theta, in that case what will happen? So if f is greater than mg sin theta, okay, so if f is greater than mg sin theta, then the body is going to accelerate in this direction. It is going to accelerate in this direction. In that case, what are going to be the equations? In the vertical directions, these two are getting balanced, so I can write r will be equals to mg cos theta in the vertical direction. Okay. Along the slope, you see, force is being acting on the body and mg sin theta is also acting on the body, and the body is moving up. Okay. Which is greater? F is greater or this one is greater? F is greater. Why? Because the body is moving up, so that's why I can say F is greater. So in this body, F is acting in this direction, mg sin theta is acting in this direction. What is the resultant force? Resultant force which is acting in this direction will be F minus mg sin theta. The resultant force which is acting on the body is F minus mg sin theta. Why F minus mg sin theta? Why not mg sin theta minus F? Because already I have said that F is greater than mg sin theta. So the resultant force which is acting on the body is F minus mg sin theta. And we know force is equals to mass into acceleration. So that is equals to mass into acceleration. Okay. So from here, if you want to find out acceleration, I can write F minus mg sin theta divided by m. This is your acceleration. This one is your acceleration. Okay. Number B. What is going to happen if f is less than mg sin theta? If f is less than mg sin theta, this also can be the case. That means I have kept the block on the inclined plane. The block is sliding down. Okay, I am seeing that the block is sliding down, and to stop that, I am applying a force. But my force is less than mg sin theta. So what will happen? If my force is less than mg sin theta, then the block is going to slide down no matter what. Okay, I am applying the force F, but this mg sin theta is greater than F. So what will happen? The block will slide down no matter what. Okay, so mg sin theta is greater than F. So the block is going to slide. In this case, you see, vertical forces, no problem, there is no motion in the vertical direction, so R will be equals to mg cos theta. This is your R. Okay. In the along the plane, you see. Now also two forces are acting. Mg sin theta is acting and F is acting. Which one is greater? Mg sin theta is greater. That's why the body is going down. Mg sin theta is greater. So if mg sin theta is greater, then what is the resultant force that is acting on the body? The resultant force over here will be mg sin theta minus F, that is equals to mass into acceleration. Okay, mg sin theta minus F, that is equals to mass into acceleration. So from here, acceleration is going to be mg sin theta minus F divided by m. This will be the acceleration. Okay. So this is the case where a force is applied in the upward direction. Fine. Next one we will see what will happen if a force is applied in the downward direction. If a force is applied in the downward direction, okay, if I apply the force in the downward direction, then what is going to happen? If I apply the force in the downward direction, so this is your inclined plane. This was the body. This is mg. This is theta. So if I divide this into two components, this is one component, this is one component, this is theta. So this one will be mg cos theta. This one will be mg sin theta. Okay. And this is going to be r. Okay. Now the block was in the block already a force was acting, that is mg sin theta, which is pulling the block in the downward direction. Now along with this mg sin theta, suppose I am also adding an extra force F. I am also adding an extra force F along the slope. Okay. So the body is going to accelerate in this direction. In this case, what is going to be the acceleration? Okay. First see the vertical direction. Okay. Vertical direction. Or vertically along the slope. Vertically. So these two are getting balanced, so no problem. So R will be equals to mg cos theta. So R will be equals to mg cos theta. Fine. Along the slope. Along the slope. Along the slope. Fine. So along the slope, you see mg sin theta is also there, and one more external force I am also acting on the body is being acting on the body, that is F. So mg sin theta plus F. This is the total force which is acting on the body. So what is the total force that is acting on the body? Mg sin theta plus F. This is the total force which is acting on the body. Okay, and that is equals to mass into acceleration. Acceleration is in the downward direction. So acceleration is going to be mg sin theta plus F divided by m. This will be the acceleration. Okay. So this is how we have to do if a body is placed in an inclined plane. Okay. So we have discussed two main important topics in free body diagrams. One is if a body is kept on a smooth plane, that means in a smooth plane surface, and over here if a body is kept in an inclined plane. Okay. Fine. Now remember, over here in all these cases I have not considered friction. If I consider friction, then there will be one more force, but that one you have to learn after. You have to do after studying the entire chapter of friction. Okay. After studying the entire chapter of friction, afterwards I will make a separate video where I will show you how to do this free body diagrams. I will show you a few examples with how to do this free body diagrams if I consider friction. Okay. Fine. Now in this video I have discussed these two things. Okay. Now I will make one more video. In the next video I will show you few more free body diagrams like pulleys, strings. Okay, if two bodies are attached to each other, how to solve. So in the next video I will show you few more free body diagrams and how to solve them. Okay, but for now, okay, this is everything in this video. I hope you like the video. If you like the video, please like and subscribe. Thank you.